Welcome back, guys. So I have got this nice problem from International Mathematics Olympiad 2001. Okay, and we'll use Holder's inequality to solve this problem. So I hope you are familiar with the inequality. Okay, so when we look at this question, I see this nasty radical in denominators, and the very first thing that comes to my mind, and probably yours, is to use Cauchy-Schwarz inequality. But that failed. I did try, and like the terms weren't cancelling out, and we were still left with the square roots, and it gets even messier. And my second instinct was to use this Holder's inequality, and because we have whenever we have this radicals thing and or big powers such as 2016, 2019, your very first instinct must be to use Holder's inequality. That is the key to the questions. Okay, so when I try to set up inequality for this, we do know the Holder inequality. This statement, it says sigma x and then sigma y I and then sigma zi is greater than this whole cube thing if we are considering the three sequences, right? And then this is going to be greater than sigma cube root of x I y I z I, right? Let me open it for you. Let me write the expanded form: x1 plus x2 plus x3. Okay, and then we have got y1 plus y2 plus y3. We have got z1 plus z2 plus z3. This must be greater than cube root of x1 y1 z1, okay, plus cube root of x2 y2 z2, okay, plus cube root of x3 y3 z3, right? And this thing whole cube, right? So we have got this statement. So we have to consider three sequences, three series. So when I have to make these three sequences, I have to make with this thing in my mind. Okay, this thing, cube root x1 y1 z1. So when I have to consider this sequence with of three terms, and then y of three terms, okay, and z of these three terms, I have to consider this x1 y1 and z1 to be in such a way that either they cancel out completely, or if they cancel out some part, and the remaining part must be cube of something. So like it must be something power raised to cube, so that this cancels out with this, and this we get linear term, and that should help us while making the sequences. So I choose this the very first thing that is given in question, okay, because we have to make left hand side actually similar to that one. So I choose a under root a square plus 8bc, right? And I choose b x2 as b under root b square plus 8ca. Third is a under root c square plus 8ab, right? Okay, so we have got this x, and now we have to choose y. So think about it. We have to remove this square root because we don't like a square, right? So my very first thing is like multiply with the duplicate of it. So when we multiply with the duplicate of it, okay, and like why am I writing all these things up? I can just copy paste because I am an iPad, yo. So I've got this. Okay, so y is pretty similar to this. So if I multiply these two terms, and then we'll get something like a square plus this thing that is under this radical. So if I multiply, I'll get something like a square and a square plus 8bc, right? So we have to choose some term here that either cancels out this completely, or like something cancels out and we are left with something. So if I try multiplying it with like a square plus 8bc, this thing will cancel out with this thing and you are left with a square, but we have to make it cube root. So try multiplying with a as well, so that it becomes a cube and we are left with a, right? This is a nice thing to multiply with. So I think I'll choose here a square plus 8bc. Hope this helps. I'm not a good explainer, but yeah, b square plus 8ca, and then you have got c square plus 8b. The key to solving Olympiad problems is always ask yourself, why are you doing what you are doing? This is the golden rule. Why you are doing what you are doing right now, like the step that you did. So you have to reason yourself for Olympiad problem. This is pretty nice thing. This is a pretty nice rule that I follow myself. Okay, so we have got this. So if I try multiplying with x1, y1 and z1 cube root. Okay, so when I multiply with these, remove this cube root for a second, try multiplying with this. So I get something like a under root a square plus 8bc multiplied with a under root a square plus 8bc and multiplied with a into a square plus 8bc. Okay, so these two multiply and this cancels out with these, and then this a is multiplied with these two gives us a cube, right? So yeah, I can say that x1 y1 z1 would equal to something like a cube. Okay, and then if I take cube root of this, I'll get something like a. Okay, so on right hand side we have got, on right hand side we'll get something like a, and if I do this same thing for this whole x2 y2 and z2, I'll get something like b. Okay, and then if I do this whole thing for this, we'll get something like c, and this is whole cube, right? Hope you did understand, because from for here we will get a, for this we'll get b, for this we'll get c. Okay, okay, so on the left hand side we are summing this whole thing. So if I have to write this whole thing, but like it's summation. So like here we have to do sum, here we have to do sum, here we have to do sum. So actually if you look at these x and y, these summations, it is actually same as this. Look, what question is saying, a and first term is same, the second thing is same, and third same is saying. Okay, so this thing is similar to what question is asking. Let it to s. Okay, let this be s, right? So this thing is similar to what question is asking, so we can let this be s as well. Okay, we can let this whole thing be s as well, and this thing is a different from question, so we will let we'll write it as it is. So on right hand side we'll get something like s dot s, and the third thing, the sum of these things. Okay, sum of these things, right? Okay, so sigma a into a square plus 8bc, right? So we have got this, and then we'll get s square plus a plus b plus c whole cube, and then you have got sigma a square plus 8bc. Okay, so when you expand this whole trinomial thing, you'll get something like a cube plus b cube plus c cube plus this 3a plus b plus c plus a. Okay, and in denominator you'll get something like sigma, open it for now, a cube plus 8abc, right? And then you'll have to write some same thing for b cube plus 8abc, c cube plus 8abc. This is the expansion of this, right? So from now here on we'll do two methods. You can continue from this with the two methods. So the method that I prefer, first we'll do that method 1, which is when you do a lot of problems on AMGM inequality, when you have practiced a lot, you would notice this thing. This seems something similar to AMGM, right? So if I apply AMGM, I do know that a plus b is greater than 2 under root ab, right? And b plus c is greater than 2 under root bc, right? And c plus a is greater than 2 under root ca. So when I multiplied these all things, I get something like a plus b into b plus c into c plus a, and then you will get something like a square plus b square, a square into c, b square into c square, and this will leave me with 8abc, right? So after doing a lot of AM question, I have memorized, I have wrote this thing with myself. You should also note this down, because pattern recognition is key in IMO problems. Okay, most of these problems require you to see and recognize patterns and triggers, and then try those things. So I tried this AM thing, and then I got like, wow, this thing is whole greater than 8abc. So if I try to plug this, if I bring it here down, okay, for a second, just let me remove this. So if I bring this down here, okay, so I can say this whole thing, I'm replacing this with like, this whole thing will be greater than a cube plus b cube plus c cube. Okay, let me shorten it down, man, this is taking a huge space. So if I have shortened it, so yeah, it's pretty good in size now. So I have to replace this a plus b plus c whole thing with plus 3 into, I'm replacing it, okay, with what I have here, which is 8, which is 8abc, yeah, which is 8abc, right? And then you have got something like, in the denominator, a cube plus b cube plus c cube plus 24abc, right? So if you look at it, the numerator becomes similar to denominator, a cube plus b cube plus c cube plus 24abc, and we have got the same denominator, so we can cancel this out. Okay, and we will get that this whole thing on left hand side will be greater than 1. Okay, since we do know that s square is greater than this whole left hand side thing, and left hand side is greater than 1, then s square is definitely greater than 1. If s square is greater than 1, then s is definitely going to be greater than 1 if you take square root on both sides. Yeah, so this is the method 1 approach, which I like a lot. But method 2 approach is which is like, when you get to like s square is greater than a plus b plus c whole cube, and then you are left with something like you are left with a cube plus b cube plus c cube plus 24abc. Okay, and if we somehow prove that this whole thing is greater than 1, so we'll win, right? Because a plus b plus c whole cube, we can expand it, we can write, yeah, for now just don't expand it, a plus b plus c whole cube, and in denominator we have got a cube plus b cube plus c cube plus 24abc, this whole thing. If we can prove that this is greater than 1, we haven't proved this for a second, we haven't proved this for yet. Okay, we are just taking this as an assumption and we're going on. Okay, so if we bring it here, we'll get something like a cube plus b cube plus c cube plus as I told you, a plus b, okay, b plus c, and then you will get something like c plus a, right? And then this will be greater than a cube plus b cube plus c cube plus 24 abc. This a cube plus b cube plus c cube will cancel out this a cube plus b cube plus c cube, and we have got 3 here as well. Okay, this 3 will cancel out with this 24, leaving you with 8abc. So a plus b plus c, and c plus a will be greater than 8abc, right? So if we now again we recognize the pattern and we apply AMGM, we'll prove by AMGM that 2 under root ab and so on. We'll prove that a plus b and b plus c and c plus a is definitely going to be greater than 8abc, right? So by using the reversibility thing, the equivalence thing, we can, now this is a truth statement. The thing is, we have reached to a truth statement, and now since every step is reversible, we can get to here and we can reverse it to here, and then we can reverse it to here, and then we'll get here. So if we continue, let's just say I gave you this thing, that this is true, and you continue doing with this, you will get something like, you will multiply 3 on the both side and you will get here 24 abc, and then you will add a cube on both side and you will get a plus b plus c whole cube on this side, and this whatever this was, a cube plus b cube plus 24 abc on this side. Okay, and then you can bring it here and you will prove that it is greater than 1. Okay, which will be, since that is proven, okay, we and s square is bigger than this whole thing, and this whole thing is bigger than 1. By transitivity, you can say that s square is going to be greater than 1 and s is greater than 1. So we proved it by 2 methods. Hope you enjoyed the videos.